Happy weekday. We're just about ready to reassemble the transmission for the Plan Z Dart. Still waiting on the students at Giles County High School to finish machining the sun shell and waiting on the soft parts, clutches, gaskets, O-rings, that sort of thing. They are taking forever. Must be being made by little elves with plaster of Paris molds, and I don't know, but eventually those parts are going to get here, and then we can get this back together. We can get it in the Dart and see what it does. So the video I want to make today is on power flow and how the power actually gets from your engine to the back of the car. Some of you guys are more seasoned in this stuff than I am and understand it better, and I probably cannot do it justice like you can. But for those of you who stop at the dipstick and the filter, you'll probably find this pretty interesting. I'm going to try to do this. This is a lot to try to keep in your mind at one time without misspeaking. I'm going to try to do it with a minimum of editing, so if I misspeak, I'll try to put something on the screen to correct it. But here we go. This is your front drum and your rear drum. This is the forward drum, comes from the rear, and this front drum is the high gear drum. Okay, so just don't confuse forward and front. I'm going to call them front and rear because that's the way they're laid out in the transmission. These splines right here are what the inside of the clutch discs are splined onto all the time, and the steels are splined into the drums themselves. With that in mind, we'll start going through one gear at a time. In first gear, we have oil pressure applying this clutch. And since the clutch is applied, it's already splined on here. It's going to be driving this ring the same direction as engine rotation. The ring gear is driving these pinions the same direction with it. Now, off the other side, remember, a gear like this changes the direction to the next gear. It's going to be turning this sun shell backwards. That sun shell going backwards is driving these pinions here. And again, it changes direction. So now these pinions are driving this ring gear in the direction of engine rotation. And since this pinion and this ring are both splined, they spline onto the output shaft here and there. I know it's hard to believe all of that just takes up this much space, but it really does. Now, this drum, it can be held in place one of two ways. If you're in drive and the car's in first gear and has yet to shift into second, there is a sprag clutch. This goes to the inner race of it. I left it in the transmission so the pieces wouldn't go everywhere, but this splines onto that. And the sprag clutch can freewheel one way and locks the other. So when you're driving in first gear, the overrunning clutch is holding this drum, which, as you can see, holds this carrier. If you start coasting faster, then you're trying to drive the car in first gear, but you're in the drive position, the car can coast. If you have the shifter all the way down in manual one, this band, and it may be off camera, but I'll bring it over here. This band is applied. So what this band does is it holds that drum whether you're coasting or not, which is okay. It'll actually give the car engine braking. The only caveat to that is if you do say you come out of the water box in first gear and the car hooks up and bites, it'll shock that overrunning clutch and can damage the sprag clutch. That's the reason why they suggest do your burnout in second gear if you can. If you can't, do it in first and upshift to second as soon as the car starts spinning tires. Now we'll move on to second gear. In second gear, this is still applied. The only change is whether the car upshifted on its own or whether you shifted the shifter into second. The low reverse band is now off and this band comes on. This band is going to put pressure on the front drum, and it's going to stop the rotation of the sun shell. When the sun shell stops, you still have this clutch on. It's still driving this ring. It's still driving these pinions, but the sun is now stationary, which means that it's no longer multiplying torque through this gear. This is just along for the ride now. So instead of having two gears multiplying torque at a 2.74 to 1 ratio or 2.45, whichever set you're running, you now have the 1.54 or 1.45 because you only have the multiplication of this gear. And that's your second gear. Third gear. For third gear, that band comes off. This clutch is still applied. This clutch comes on. So now what we're doing, we're driving both this ring gear, and because this is now being driven in the direction engine rotation, it's driving the sun gear. And the ring and the sun are going the same speed, which makes all of this just 1-to-1. Because now you've taken out the multiplication of both this gear and this gear. And we have direct drive. Now, reverse. Hopefully you'll stop first before going into reverse. But in reverse, this is finally disengaged, so we no longer have the forward clutches on, but these clutches are on, and this band is on. So now, with this clutch pack on, we're driving the sun in the direction of engine rotation. As you know, it's going to reverse when it comes off of here, because now we're driving the sun, and that's going to be turning this ring gear backwards. And that's how we make the car go backwards in reverse. And in neutral, nothing's applied. No clutches, no bands. Now I want to show you guys how one of these clutch packs actually applies. This one is already popped apart. There is a little snap ring that holds pressure on this spring. The spring is what keeps the clutch pack off. Hydraulic pressure is what applies it. So this is loose just to show you the parts, but there's this snap ring. It's a weighty snap ring, which cushions the application and sets down extremely loudly on the desk. There's this coil spring. We have, and we've shown this in other videos, we have the pressure plate and the clutches. Right here. One more steel. And this. There's the piston. You can see the O-ring. You can see how it works. There's pressure applied that pushes this piston up, and that's what pressurizes the package of clutches there. The one for forward, it's substantially similar. There is just a different kind of spring, but it's a similar deal. If you want to see how this sun shell rotates backwards, check this out. Put on a ring. Put in that carrier, our sun shell. And we'll put in that gear. And I'm going to turn this, and I've got to turn it by the pinions, but I'm turning it clockwise, and the shell is rotating counterclockwise. Needs more cowbell. Here's the inside of an empty case. And this is how the second gear applies. So if you remember, we apply a second gear to stop the sun shell. This servo right here applies with hydraulic pressure and lifts this lever, which connects to this strut, which hooks into that band. And when it does, it squeezes the band against that drum. You can get more mechanical advantage by using different ratio levers, and that's why these come in different ratios from 2.9 to 5.0. The low reverse band is still in this particular case, as is the drum, but check this out. The sprag clutch is in here, and I'm going to show you a separate picture of the overrunning clutch or sprag clutch, but here's the function of it. I can turn it one way, but not the other. This one is working just like it's supposed to. If that band was applied, I couldn't turn this either direction. This operates the same way. It has a servo right here and applies pressure on the band. Now this goes to the accumulator. The accumulator is a piston with a spring on it, and it acts basically like a shock absorber for the 1-2 shift. In a performance application, take that big spring out of there, throw it away, make a little piece of steel or aluminum or whatever. Shoot, I think you could use PVC if you wanted, and block that piston up, and you get rid of that shock absorber for a much snappier 1-2 shift. Here's your front pump. This is the side you're used to seeing. It's the side that the torque converter goes up against. Inside here, past this seal, there are 2 lugs that the torque converter drive. That's how this pump is being driven. This is the other side. And and for reference, remember the bevel from the last video. That's where this corresponds to that front drum, high gear drum, drops down on there. It seals right here. We showed the inside of this, but I don't think we talked about the function. Here is the pump itself, and when you see people measuring pumps, when they see if they're still good, they'll typically measure this clearance in here. This pump will actually draw a low pressure area in here and pulls the fluid in. That's how it does its work as a pump. It's very similar to the oil pump in cars. Works the same way. Of course there's different designs of pump, but that's how this one works. It's just an oil pump, but instead of the engines, for the transmission. These are the 2 lugs right here that your torque converter locks into. If you've ever seen anybody break a pump trying to install an engine or transmission because they did not have the torque converter seated all the way, this is where it went bad. It was those right there. They didn't have the torque converter seated all the way into those lugs, and when they bolted it down to the bell housing, it snapped it. And I've done that, and a lot of other people have done that, but that's why you spin it around until you're confident that you feel it click into those. This is indeed the check ball that the non-lockups don't have. This is a lockup pump. This pump looks a lot better than the pump that came out of the 904 for Plan Z, so I'm going to plan on taking that one out. Upon reassembling, we'll use this pump. Then here is the valve body. I am not even going to pretend to be able to tell you all of the internal functions of this thing. I can hit the high spots. Your 1-2 and your 2-3 shift valves are in here. You adjust the pressure right here. This is the manual valve. We'll try to get a good shot of that. I wasn't able to show this very well in the video, so we're going to do this on the desk here. This is in park right now. So if I can move that up. Neutral, drive, 2 of 1. Back through all of the gears. We're in reverse, that's park. You can see that detent ball right there. That's what you feel when you move the shifter. This lever right here controls throttle pressure. It's what opposes governor pressure. So when you push on the gas pedal, this is what's moving back and telling the valve body through that piston right there how much throttle pressure to oppose the governor pressure. The more throttle pressure, the later it shifts. The more governor pressure, the earlier it shifts. These two oppose each other all the time. So, and there's the manual valve that we couldn't see cycling in the video. That goes deep into the valve body. This thing goes back and engages park. And park, we'll show you that when we get to the output shaft. But I can't do an adequate job of explaining everything in here, not even close. But there are springs in here you can change to affect when the car upshifts and downshifts, and certain limits on things like how long it can hold first gear. But this thing, you gotta have an operating table, you know, practically. It's gotta be really clean inside. I'm going to attach a bunch of still shots, basically make a slideshow of where I went through this and cleaned everything out. There's a lot of little modifications to make, but it's basically, inside this thing, it is basically a computer that works off of fluid instead of electricity. It's the best way I can describe it. And then here's the output shaft. Of course, this is where your front pinion splines on, the rear ring splines on. All of that is compacted into this little short area. The high gear drum would be here. The forward rear drum would be there. There, of course, is a bearing. Then this is what runs your speedometer pinion. I'll just insert a picture for that. But that's what this is. And this, well, remember the park rod that I still have attached to valve body? It drops a parking pawl into this. And so when you hear a car where, let's say it was parked on a hill, and they pulled it out of park and it made a really loud popping sound, well, that was this disengaging. This is the governor housing right here. Yeah, got it oriented the way I want. This is pretty neat. So as the vehicle has speed, regardless of engine speed, this output shaft is going to be turning at whatever speed the drive shaft is. So however fast the car is going, this is being spun faster. and it uses this. You know, so if you can see this, with centrifugal force, this thing is going to move out. It allows this piston to move further to the outside, which in turn allows it to, and I don't know if you can see that, but it allows it to move this valve and change the fluid passage that's covered up in here. So that we change the signal to the valve body. And that's how the car knows when to upshift. So when we want to raise our shift point, a lot of people go a lighter governor weight because it's going to take more RPM to spin this to the outside to move that valve. Here's the torque converter. There's not much to see from the outside of a torque converter. We have this side that bolts to the engine. We have these lugs. These are what engage those two lugs in the pump to turn it. And converters are an amazing science. And you might see a name that kind of recurs in the comments. His name is Mike Iben. Mike Iben builds torque converters for a living. And he knows all kinds of stuff about these. I'm just going to give you a basic overview of how this thing actually makes your transmission turn. This side bolted to the engine, and then that ring gear so the starter can turn it. Inside of here, you have this outer shell we commonly call the impeller. On the back side, you have a corresponding shape which looks similar. It's the turbine. The turbine is splined to the input shaft from the transmission. I'm going to drop some still pictures of these in there so it'll make more sense. Inside here, you have a third piece in the middle called the stator, and it's going to spline onto the front pump on that splined part of the pump on the outside. And then, as I said, these go inside the pump and hook up to the pump gears inside. When the engine turns, it's spinning this outer shell. And through two processes of fluid flow, it's turning that turbine against the stator. That's what multiplies torque and drives the vehicle forward. But anyway, there are much better, more detailed videos about how torque converters work and the science. I just want you guys to basically have an idea of what's driving the car forward. We're using fluid pressure, and we're driving the turbine in here, and the turbine is what's driving the input shaft. That's what's driving the transmission. I hope you guys found that interesting. Next video, we're going to show some machine shop action and then reassembly, and then we're going to take this thing and put it in Plan Z and see what it does. Hope this was helpful or at least interesting, and stay tuned. The sun shell, supported by a Dr. Pepper can, which should not be in your transmission, but it holds the sun shell up nicely. This is going to be a challenge. Take 47 or whatever this is. Maybe I have the wrong ring gear. I bet I do. Might. I sure do.